Welcome to my video on 6 trigonometric functions of acute angles. So what we'll look at here is the case of a right triangle. So I'll draw a right triangle here. And a right triangle has a 90-degree angle, so that's our 90-degree angle. And this is going to be angle theta. This is the angle they're interested in. Now we define the different parts of a right triangle, the side opposite of the angle theta, we call that the opposite side, and we're going to make it a quantity b. The long side here, opposite the 90-degree angle, is called the hypotenuse. And we're going to label that c, have a length c, and that leaves the adjacent. It's adjacent to the angle theta, and we're going to have to give it a length of b. I'm sorry, of a. Okay, so there's our definitions. Now let's write the trigonometric functions associated with that. Okay, first of all, we do define the sine of the angle theta, and that's going to be equal to the ratio of the opposite over the hypotenuse, and that is just going to be b over c. Angle b, which is the opposite, over the hypotenuse, the length of c. And the next one we want to do would be the cosine of theta. It is the ratio of the adjacent side to the hypotenuse. And numerically, we're going to write that as a over c. And the third one we want to define is going to be the tangent of theta. It's also another ratio, but it's two different lengths of the right triangle. It's going to be the opposite over the adjacent. That's going to be equal to b over a, whatever those length of those lines are. Now we can define three more that are reciprocals of these three functions. So what we can do is we can do the cosecant of theta, that's CSC of theta. And now that is going to be the hypotenuse over the opposite, that's c over b. And you can see that that is just, there's the b over c for the sine, and then c over b for the cosecant. So it is just the reciprocal. Now the secant function, secant of theta, is going to be equal to the hypotenuse over the adjacent. That's going to be c over d. Sorry, that's c over a. Yeah, the hypotenuse over the adjacent, c over a. And we can see also that this is just the reciprocal of the cosine. Now the cotangent, as you're probably going to guess, is the reciprocal of the tangent function, so that's the adjacent divided by the opposite. That's going to be the ratio of a over b, which is just the reciprocal of b over a for the cotangent. So there's our 6 basic trigonometric functions relative to a right triangle. So next, let's do an example. I'm going to draw another right triangle here, a little different one. And let me get rid of that spot there. Okay, there's our right triangle. There's our 90-degree angle. And we're going to make this side of length 3, this side of length 4, and this side of length 5. So this is our hypotenuse. It's opposite the right angle. This one is going to be our opposite, since it's going to be opposite this angle theta, the one of interest. So that's our opposite. And then this would make this the adjacent. So there's how we label our right triangle. So what let's do, let's try to figure out what the sine, let's use all these different functions and figure what their numerical value would be. Sine of theta, we know that that is the opposite over the hypotenuse. That's equal to b over c, which is equal to 4 over 5, because it's 4 divided by 5, the opposite over the hypotenuse. Now the cosine of theta is the adjacent divided by the hypotenuse, and that is A over C, which is 3 over 5. The tangent of theta is equal to the opposite divided by the adjacent, which is B over A, and that is 4 over 3. So there's our three basic functions. Now let's look at their reciprocals. Let's look at the cosecant. Cosecant of theta is going to be equal to the hypotenuse divided by the opposite, and that is C divided by B, which is 5 over 4. And now we can notice that the sine and the cosecant are reciprocals of each other because it's 4 over 5 here and 5 over 4. So that checks with what we had earlier. Now let's do the secant of theta. And that is going to be equal to the hypotenuse over the adjacent side. C divided by A, 5 over 3. Now that should be the reciprocal of the sine. And so yes, the 3 over 5 is the reciprocal of 5 over 3. So those match. That makes sense. And then our last one is our cotangent. Cotangent is equal to the adjacent over the opposite side, 3 over 4, which is equal to A over B. Now let's see if that's our opposite. Okay, there's 4 over 3. Here's 3 over 4. So we can see that 3 over 4 is the reciprocal of 4 over 3. So the tangent and the cotangent are reciprocals of each other. So there's our basic definitions and one example on a simple triangle. Hope you got something out of this and learned about some of these trigonometric functions, and I want to thank you for watching.